Okay, so we're going to demo Lab 4 for you, and what Lab 4 does is we have a motor here that's controlled by a user's input, and then also the motor responds to stock prices. So Greg is going to show you the first part, which is how the motor works, how it responds to a user's input and calibrates, and Andrew will go over the second part, which is how we respond to changing stock prices. So to go over the hardware here, you can see we have two different breadboards separated by this isolator. Now this side, the Arduino side, actually runs on 3.3 volts, and the isolator is used to separate it from the 12 volt side, which is required for the motor to run. Now we also have a Darlington transistor here, which is used to control the current, a diode to make sure the current doesn't flow in the opposite direction, and a capacitor here to store energy, and a signal filter. So you'll see we actually hooked up the new TFT LCD display that we recently got. So this is actually operating in high speed mode. There's a slow speed mode for some reason, and also a high speed mode. So it uses the SPI hardware of the Arduino. So you can see we're actually using 5 pins to drive this, and we'll show an example of how this works later. So over here on the motor, of course the motor is just enclosed in this basic Lego contraption here. Now we have this spinning wheel that has this disc attached, and there's an alternating spoke and space pattern. And so Greg will show you that we actually use these two, infrared receiver and infrared transmitter, to figure out when we're over top of a spoke and when we're over top of a space. And so that alternation there will tell us how fast the motor is actually spinning.
I'll talk about how we go from the infrared sensor to actually having an estimate for our RPM. As Eric talked about, we have an infrared LED and an infrared sensor, and they look through the spokes, and as each spoke passes in front of the sensors, you get alternating patches of signal and no signal. When you look at that in an oscilloscope to see the actual signal, it looks kind of like this. You have a peak and then a long trough. And we tell the Arduino to look for portions like here where the signal is rising. If you time this interval, well, that's the interval between different spokes. And you can imagine how if you can tell the time between spokes and the number of spokes in a wheel, well, you can get the rotation rate, right? Sort of. We're using a microcontroller that's used to signals that are electronic and on the order of nanoseconds. Our signal comes from an infrared sensor, and this signal is in the order of milliseconds. So it's very, very slow. And as it happens, certain things go wrong. We have to correct for. The first thing is our rising area here takes so long that sometimes the Arduino screws up and thinks that one rising area is actually 2 or more. To correct for that, whenever the Arduino realizes there's a rising area that we care about, it then ignores all the ones that follow it for a certain window. The second thing that can go wrong is our signal is so noisy that even where you and I know this signal is falling, and so we don't want the Arduino to think this is a spoke, it'll actually pick up on very small noise there and think it's a rising edge. And so we can end up with the Arduino thinking this interval corresponding to 1 spoke actually is this interval and this interval corresponding to 2. Finally, the Arduino can screw up entirely and miss a rising edge entirely. When it does that, the Arduino thinks that this interval for a spoke and this interval for a spoke is actually all one interval. And all these things interact to mess with our RPM estimates. I've gone over how we deal with double detections. We simply tell the Arduino to ignore it for a while. You can actually correct for these incorrectly placed detections by looking at how long the intervals are and making sure they all look reasonable. So for example, if my spokes are passing in front of me at, let's say, 10 seconds per, you're expecting a series of 10-second intervals. If all of a sudden you get 10, 10, 10, 20, 10, 10, then you realize that's a double interval, and you can correct for that. Similarly, if you see 10, 10, 10, 3, 7, 10, 10, 10, then you've got an extra detection, and you can correct for that too. Putting this all together, we take a very noisy signal from our infrared sensor and convert it to a very reliable estimate of our RPM at any given second. So here we are already running. we've told the system to run at 100 RPM, and you can see how we are calibrating as we go to maintain a even rate. If I tell the Arduino to accelerate to, let's say, 120 RPM, the Arduino quickly looks up a reference value, something we've told it is kind of close to the power it should be using. And from there, it tweaks slightly and slowly to stay near the target rate. If I set it to 80 instead, it will do the same thing. It'll quickly switch to somewhere to a good estimate, and then calibrate over time. Like so. Alright.
Alright, so now we're going to show you guys our real world demonstration. So what we decided to do was track the stock prices for Google and allow the user to input a target strike price, so a price when they want to purchase the share. So when the current stock price of Google reaches that target strike price, this wheel will spin at its maximum speed. So as the price creeps up and gets closer and closer, the wheel will speed up faster and faster. So unfortunately the stock markets are closed today since it's Good Friday. So what we did instead was pull out historical data from just previous month, and we'll show you this demo right now. So upon initialization, the user is prompted to enter stock market mode. Great, let's enter that. So we're going to start, here's a Python script that we have that allows you to input the company that you want to track along with the start and end date for the historical prices. So on this date of February 20th, the price was $794. So let's say we want to have a target price of $814. So we want to know when to buy when the price reaches $814. So let's enter that price and then start setting historical data. So the wheel's turning slowly because so our LCD screen here displays the price. The price just went up to $802. Okay, so the wheel's spinning up. Oh, jumped up to $812. That's so close to our strike price. So it's starting to rev up. Oh, but then it dropped, $809. So next day, $810. So it's getting closer again. There we go. Hit our target strike price, so the wheel will rev up to its max of 130, but then the price dropped again. Yeah. So definitely in the future, when the market's open, you can actually call our script and it'll pull real-time data. But yeah, we're using historical data.